Hello, I'm Mayank, and I shall be showing you how I'll be constructing the matrix as shown over here using the Kronecker product. Meanwhile, Priyansh in the previous part had shown how he constructed the matrix via the theoretical definitions, and over here I shall be using the method of Kronecker products. So then let's start off with the original definitions of Sx, Sy, and Sz as shown before with the relation to the spin operators. So now spin operators are the main defining parts of a Heisenberg system, where usually an electron would have a spin that is intrinsic to it. A Heisenberg system has spin via spin operators. So then these spin operators have certain Pauli matrices. For example, let's say that we have sigma x is equal to 0, 1, 1, 0, and sigma z is equal to 1, 0, 0, minus 1. All right. So then we'll be defining the Kronecker product. Sigma x circle with across sigma z as a huge matrix where we're going to explicitly state out block elements, as I say. So then we'll have one matrix on here, another matrix on here, another matrix on here, and another matrix on here. The question is which matrix shall go where? And that answer shall be given by le- multiplying the first element of sigma x 0 0 to sigma z, sigma x 0 1 to sigma z, and so on. So then let's create this matrix to illustrate the example. So I'm erasing it right here, and we shall show how it works. So we'll start with the first element, that is 0. So we'll have a block of zeros on here, 1. So we'll have a block that is similar to the original matrix. 1 again, which is similar to the original matrix. This one, and 0, which is the last one. So this shall be the Kronecker product for sigma x cross sigma z as an illustration. So as we see here, a 2 cross 2 matrix Kroneckered with a 2 cross 2 matrix shall give us a 4 cross 4 matrix. And now similarly, as you can see over here, we'll be having an n-spin isotropic Heisenberg model with certain different cross products of the S this. So as a result, the resulting Hilbert space shall have a total of 16 cross 16, 16 plus 16 elements. Yeah, 256 elements. So then here's the Python code for this, and just to show you how it can be implemented, got the code on here, and let's run it and see what it gives us. So over here, we have stated out the operators and everything. And yes, here we go. Here's the code followed by the heat maps. So now a heat map will help us understand all the garble over here. So then the purple bit we see over here is a set of all zeros. And if you notice, this heat map that shows out the pattern is similar to the one which we had in Priyanka's document, which is right here. So then I've included my variation right here. So you can see as it is same to same. And here's the structure. So here we have a 1 cross 1 block for S of Z is equal to plus 2, a 4 cross 4 block for S of Z is equal to plus 1, a 6 cross X block for S of Z is equal to 0, a 4 cross 4 block for S of Z equal to minus 1, and a 1 cross 1 block for S of Z is equal to minus 2. So then we have created this matrix using using the Kronecker product, and we have some notes as well. So then we can generalize this into any n just by changing a certain value, and as a result, we can get changing certain value in the program. We can get it for any n. And then second one, to include a magnetic field, we just add the Hamiltonian we have with the magnetic field times S of Z power k. So then and we also have some certain notes given over here, and thus it shows how we can generate a matrix. Thank you, and Janam shall be continuing to the next part.